Hello everyone, I am Mrs. Rushali Chaudhary, lecturer, Praveen Patil Polytechnic. Today we are going to learn metal corrosion, its prevention. That's chapter 2, basic science, chemistry. Learning outcome of these videos is protection of metal from the corrosion. In that we are going to learn cathodic protection. Corrosion, the process of destruction of metal. Due to that, lot of damage will occur for the industry as well as the human life. So we have to learn how to protect metal from corrosion. In the last lecture, we studied different methods to be used for the protection of corrosion. Last lecture, we used change in the environment. That is a removal of corrosion constituent and using a corrosion inhibitor. But always it is not possible to change the environment. So we are going to use a different technique that is called as potential change of metal. In that, anodic protection is there and cathodic protection. We are going to learn cathodic protection. That is take place in a two ways called as a sacrificial anode and impressed current. What is the cathodic protection? When metal undergoes corrosion, that is behave like an anode and undergoes loss of electron. But what happens in the cathodic protection? We are forcing the metal to behave like a cathode, so corrosion will not take place. How that will possible? That is possible by using two techniques, that is by using a sacrificial anode and by using an impressed current. In a cathodic protection, the base metal to be protected is forced to behave like a cathode and protected from corrosion. In this we are using a sacrificing anode. In this method, the metallic structure to be protected is connected by a wire to a more anodic metal, more reactive metal, so that corrosion is concentrated at the more active metal and base metal will remain as it is. The active metal will undergo corrosion slowly and the base metal become cathodic and get protected. The more active metal is used as a sacrificial anode. Whenever the sacrificing anode is consumed completely, it is replaced by the fresh one. This diagram shows you sacrificial anode. See this is your underground pipeline. This may be a water pipeline, electricity pipeline or the gas pipeline that is made up of metal. When they are contact with the wet soil, this metal will become anode and undergoes corrosion. And if there is a leakage or the destruction of pipe take place, that is going to cause a major problem. Consider if it is a gas pipeline and there is a leakage. So how we are going to prevent it? We are going to connect this pipeline with another metal which is more reactive, that is having higher position in a galvanic series by a insulated wire. So what happens? This pipeline and this metal both are different and connected with each other in presence of wet oil. As per the electrochemical cell or electrochemical corrosion, the more active metal will become an anode and undergoes corrosion. Less active metal will act as a cathode, remain as it is. So here aluminium or magnesium or zinc will become anode and undergoes corrosion and deterioration. We are using the reactive metals like magnesium, zinc, aluminium and their alloy as a sacrificing anode. This method is used for protection of underground buried pipelines, underground cable, marine structure, ship hulls and water tank to prevent from corrosion. Next method is impress current. In this, we are externally supplying current, so base metal or the structure will behave like a cathode and protected from corrosion. In this method, an impress current is applied in an opposite direction to nullify the corrosion current and current the corroding metal from anode to cathode. The impress current derived from direct current source like a battery or AC line with an insoluble anode like a graphite, high silica ion, stainless steel or platinum. Sufficient DC is applied to an insoluble anode buried under the soil and connected to the metallic structure to be protected. The anode is buried in a black fill such as coke, bridge, gypsum to increase electrical contact between itself and the surroundings. This is your underground pipeline. This is connected to the DC source, the wire. So this pipeline will act as cathode. Positive will attach to the graphite, stainless steel, so it is remain as it is. This is the small battery. When the battery get completely discharged, we are replaced with another battery. So pipeline will act as cathode and protected from corrosion. This type of protection is used in buried structures such as tanks, pipelines, transmission line towers, marine pliers, ships. Advantages: they can be automatically controlled, which reduce the maintenance and operational costs. As the corrosion is decreases, the operational and maintenance cost of pipeline is automatically decreases. MCQ based on this: anodic coating protect the underground metal. How this they are going to metal? Because they are sacrificing. Anodic coating undergoes itself corrosion and sacrificing itself, and protection will take place. When the buried pipeline is protected from corrosion by connecting to a magnesium blocks, then it is called as sacrificing Cathodic protection. We learn only the Cathodic protection, so sacrificing Cathodic protection. Thank you so much. Thank you for your attention. If you have a doubt, mail me. Thank you.